At this moment inside your body, a hidden empire is holding itself together with almost absurd precision. Not a single wall, but millions of them. Not one ruler, but countless cells obeying signals so tiny they vanish beneath the noise of life. And when that empire starts to fail, when the scaffolding gives way, the consequences are not abstract. They are felt as pain, swelling, weakness, blindness, paralysis, breathlessness, and sometimes silence. We're talking about tissue, the living material that makes every organ possible, every movement possible, every thought possible. And here's the strangest part. Tissue is both ordinary and miraculous. It is the stuff we cut with a knife, scrape from a wound, freeze in a lab, and examine under a lens. Yet it is also the reason you can stand up, remember your name, and survive long enough to hear this sentence. To understand tissue, we have to start before it becomes bone or skin or muscle. We have to go back to the first chaotic decision life ever made, to stop being a single cell and become a civilization. That was the original gamble. One cell can survive on its own, but a colony can build a body, and bodies, unlike lone cells, can specialize. Some cells became barriers, some became pumps, some became messengers, some became the silent support behind the stars of the show. That choice changed everything. It meant life could grow bigger, move faster, heal better, and survive in harsher environments. But it also meant life became dependent on coordination. One mistake in one patch of tissue, one weak connection, one corrupted repair process, and the whole system starts to wobble. Long before microscopes gave us the language to name these structures, people could feel them in the wounds they dressed, the tumors they feared, and the dead flesh they burned to stop infections. They knew the body was not one smooth substance. They knew there were layers, fibers, membranes, gristle, flesh, nerves. The body had texture, it had architecture. The word tissue itself eventually became our way of describing that architecture, but the reality existed long before the label. In the earliest days of anatomy, physicians and natural philosophers tried to make sense of what they found under skin. They saw that organs were not carved from a single material but assembled from repeating building blocks. They discovered that a liver felt different from a lung, that a tendon snapped differently from a vein, that skin had a grain like woven cloth. Even the word tissue carries that old idea inside it, something woven, something made of threads. And that is exactly what the body does. It weaves, it braids cells into working units, it stitches function into form, but this weaving is never perfect. It is always under pressure. Imagine a city built in darkness where every building is still under construction while traffic already rushes through the streets. That's tissue. Every second, cells divide, mature, die, and get replaced. Waste must be removed, nutrients must arrive, oxygen must diffuse through microscopic corridors, signals must be sent and answered, the surface must stay sealed, the interior must stay organized. And if that sounds delicate, it's because it is. Tissue lives in a constant negotiation between stability and change. Too little change and it becomes rigid, scarred, old. Too much change and it loses identity, becomes disordered, and may turn dangerous. The first great breakthrough in understanding tissue came when observers realized that not all tissues are created equal. There are basic families, each with a different job, each with different microscopic architecture. Epithelial tissue forms boundaries. It covers skin, lines the gut, wraps glands, and creates the body's front line. Its cells are packed tightly like cobblestones pressed together to stop leaks. Underneath, connective tissue acts like the body's framework and packing material. It includes loose support, dense fibers, fat, cartilage, bone, blood, and all the materials that hold things in place or move them around. Muscle tissue is the engine built to contract with force. Nervous tissue is the wiring transmitting rapid electrical signals that let the body react to the world in real time. Four broad categories, four different solutions to the same problem. How do you turn a cluster of cells into a living machine? But these categories are only the surface. Beneath them lies a more dramatic truth. Tissue is not passive material, it is active politics. Cells vote with chemical signals, they bargain through contact. They obey local rules, then change the rules when the environment shifts. A skin cell on your hand is not the same as a skin cell on your face. A cell in the liver behaves differently from one in the heart. The same genome can produce wildly different outcomes depending on the neighborhood. That means tissue is not just about what cells are, but about where they are, who they touch, and what messages they receive. We tend to think of the body as a machine with parts, but tissue reveals something stranger. The parts are constantly negotiating their own identity. Now let's get to the real engine beneath the theory. The reason tissue matters is not just that it exists, but that it must endure damage and repair. Every day your tissues face an assault campaign. Friction, toxins, pathogens, ultraviolet light, mechanical stress, temperature shifts, and simple wear and tear all chip away at them. Skin tears. Lining of the gut gets battered by enzymes and acid. Muscle fibers micro-tear during exertion. The tiny air sacs in the lungs are exposed to a hostile external world with every breath, yet most of the time we don't notice. Why? Because repair is happening at a scale so small it feels invisible. Cells sense damage, they release signals, blood vessels widen, immune cells flood in, clots form, fibroblasts lay down new fibers, epithelial cells crawl over the wound, new tissue grows in layers. Some of it is temporary, some of it becomes permanent scar. And scar is where the story gets emotionally complicated. Scar tissue saves lives, it closes wounds, it prevents bleeding, it protects the body from open catastrophe. But it is also a compromise. Scar is less flexible, less specialized, less elegant. It is the body saying, we survived, but we had to accept a loss. That loss can be tiny, like a cut that leaves a pale line, or enormous, like the aftermath of a deep injury that changes an organ forever. The repair process is not a return to the original state. It is a negotiated settlement, a peace treaty written in collagen. If you're obsessed with decoding how living systems build, repair, and sometimes destroy themselves, hit that subscribe button. We unmask the hidden mechanics behind the body's most extraordinary structures every week. Now let's go deeper into the tissue-level war happening beneath the surface. One of the most fascinating things about tissue is that its cells don't just sit there waiting for instructions. They are constantly reading the environment. They detect pressure through the cytoskeleton. They detect neighbors through adhesion molecules. They detect nutrients, oxygen, and waste products through membrane receptors and gradients. In other words, cells are not little bricks. They are sensors. And the tissue is the environment those sensors collectively create. That's why tissue can change its behavior when it is stretched, starved, inflamed, or invaded. A tissue under pressure can thicken. A tissue deprived of oxygen can call for new blood vessels. A tissue repeatedly injured can harden and remodel. In biology, structure follows stress. Over time, the body writes its history into tissue, the knotted shoulders of an overworked adult, the thickened skin on the hands of a laborer. The stiff vessels of aging, the calcified valves of a heart that has spent decades pushing blood through a narrowing path. Tissue is memory with consequences, and this is where the microscopic world becomes almost literary. Every tissue contains stories of survival and compromise. Cartilage cushions joints but heals poorly because it lacks direct blood supply. Bone is rigid but also alive, constantly being broken down and rebuilt by specialized cells. Blood is a tissue too, though many people forget that. It is fluid connective tissue, a moving transport network carrying oxygen, hormones, immune cells, nutrients, and heat. Even fat tissue, dismissed so often as mere storage, is a living endocrine organ that sends out chemical messages affecting hunger, metabolism, inflammation, and reproduction. There is no useless tissue in the body's original design. There are only tissues whose roles we have misunderstood. And once we see that, the entire body changes shape in our minds. The heart is not just a pump. It is muscle tissue organized into a synchronized wave. The brain is not just a thinking machine. It is nervous tissue layered into networks, support cells, insulation, and microenvironments. The lungs are not just empty sacs. They are fragile sheets of epithelial tissue spread over a surface area so vast it rivals a playing field, all to exchange gases across a barrier thinner than paper. Think about that. The body has built an interface so delicate that life depends on it, and so extensive that a tiny disruption can be catastrophic. Tissue gives us scale and vulnerability at the same time. The hidden drama gets even more intense when we look at development. In the womb, tissue formation is a masterclass in timing. Cells don't become everything at once. They follow gradients, signals, and positional clues. A cluster of embryonic cells has to know when to become nerve tissue, when to become muscle, when to become connective scaffolding, when to fold, when to migrate, when to stop dividing. Misread one signal and development can veer off course. Tissue can form in the wrong place, fail to close properly, or grow into shapes that make survival harder. The stakes are enormous because there is no backup copy of the body under construction. Every step has to land. Every layer has to align. Meanwhile, hidden behind all this elegance is the darker reality. Tissue can also become the site of exploitation and failure. In disease, tissue structure is often the first thing to collapse. Infection can destroy architecture. Autoimmune reactions can make the body attack its own tissues. Fibrosis can thicken tissue until it suffocates function. Cancer begins when cells stop respecting tissue boundaries and start behaving like rebels with no loyalty to the system. They ignore the local rules. They multiply, they invade, they recruit blood vessels, they hijack the tissue environment and turn it into their own growth engine. In that sense, cancer is not just a problem of rogue cells, it is a problem of broken tissue governance. The neighborhood fails, the law disappears, the city becomes dangerous from within. But tissue science has also given us one of the great modern revolutions: the ability to look inside the body without opening it and to study biopsies, stains, and cell layers in exquisite detail. Under the microscope, the body reveals its grammar. Thin slices show the arrangement of cells, nuclei, fibers, blood supply, and damage patterns. Pathologists read tissue like investigators reading a crime scene. They can tell inflammation from infection, benign from malignant, degeneration from repair, old injury from fresh one. A tissue sample can answer questions that symptoms alone cannot. It can reveal what the body is doing when nobody is watching, and that has transformed medicine. It means diagnosis can move from guesswork to evidence. It means treatment can be tailored not just to a disease name, but to the tissue behavior beneath it. Now step back and look at the larger legacy. Understanding tissue changed how we see life itself. It taught us that complexity doesn't come from magic, it comes from organization. It comes from cells cooperating in layers, from boundaries that hold, from scaffolds that support, from signals that coordinate, from repair systems that never quite stop working. It changed surgery, pathology, transplantation, wound care, regenerative medicine, and the entire idea of what it means to heal. It opened the door to growing cells outside the body, engineering replacement tissues, and imagining a future where damaged organs might be repaired instead of replaced. That future is still unfinished, and maybe that's the point. Tissue is never a solved problem. It is a living compromise between breakdown and renewal. Every second, your body is trying to preserve what it is while becoming something slightly different, not all at once, not cleanly, but enough to stay alive. And if that sounds like a biological process, it also sounds like us. We are made of the same logic. We survive by rebuilding ourselves after damage. We carry scars. We adapt. We keep our shape by changing it. That is the quiet power of tissue. It is not glamorous. It does not demand attention. It holds the line. It is the invisible contract between chaos and continuity. And the more we understand it, the more we understand why life can be both fragile and stubborn at the same time. So when you think about tissue now, don't think only of a sample on a slide or a bandage on a wound. Think of the entire hidden infrastructure of being alive. Think of the woven boundaries, the living support beams, the electrical highways, the repair crews, the failures, the scars, the rebirth. Because once you start seeing tissue for what it is, you stop seeing the body as a collection of parts. You start seeing a world. And if you want to keep exploring the strange machinery that makes that world possible, stay with us. Subscribe, and let's keep pulling back the curtain on the hidden systems that keep life stitched together, one remarkable layer at a time.